SSBRadioschool.com.
Oscar. Whiskey ending, whiskey. Whiskey 6 ending, whiskey again. Whiskey 6 Yankee whiskey 59.
This is single-sideband phone operation on the 10-meter band. Compared to FM phone, single-sideband is noisier and has lower fidelity audio. It is more susceptible to interference from natural or man-made sources, such as lightning or RF emissions from electrical devices.
It's possible.
Kilo Juliet 4, United Golf Oscar, 59 plus.
He's in Czechoslovakia.
Single-sideband phone is a special form of amplitude modulation that is very popular on the HF bands, including the 10-meter band phone segment available to technician class licensees from 28.3 to 28.5 MHz. Single-sideband phone is also used in certain segments of the VHF and UHF bands, such as the popular 6-meter, 2-meter, and 70-centimeter bands, also available to technician class operators. Single-sideband phone operations are quite different from FM phone operations on simplex channels or with repeaters. Typical FM operations on the VHF and UHF bands are conducted in compliance with local band plans that identify specific frequencies for simplex channels and repeaters. These specified frequencies or channels are intentionally separated across the band so that the bandwidth of an FM signal, nominally 5 to 15 kHz, will fit within the frequency range of the separated channels and thereby avoid interference between operators using different channels. With single-sideband operations, no channelization is specified, and operators are free to tune contiguously across the band with a fine-tuning resolution, typically as small as 10 Hz steps with most transceivers. The bandwidth of a single-sideband signal is typically about 3 kHz. The single-sideband receiver in upper sideband mode will demodulate into audio a 3 kHz band of frequencies above the tuned frequency value on the display, called the carrier frequency. This range of frequencies adjacent to the carrier is the receive band. When the receive band is properly aligned with a signal transmitted by another station, that signal is demodulated by the receiver and the sound of the transmitting station operator's voice is received.
You were actually one of the states we were looking for on 10 meters, thank you. You look after yourself, mate. Good health to you and yours. And again, well done on that sterling job you lads over there in Wyoming are doing at the moment. Whiskey 7, Mike Golf Bravo, G0 Delta Bravo Echo. See you later, lads.
Notice that while tuning across the band and encountering a signal, the audio of the signal changes. The tone of the received audio shifts higher or lower, and the quality or intelligibility of the audio changes as well.
Gonna tune this guy in.
Actually, a pound cheaper to fly than to take the boat, so why take the boat for a pound less you can fly over in a very short time?
These audio effects are the result of a misalignment or a changing alignment between the received signal's position in the band and the receiver's tuned position in the band. For instance, as an upper sideband signal is approached from the lower frequency side by changing receiver tuning, the lowest frequencies of the signal are initially aligned with the received band's high frequency positions. As a result, these lower frequencies are incorrectly demodulated into relatively high-frequency audio, causing the voice of the other operator to sound distorted. As the signal is tuned in and properly registered in the receive band for demodulation, the audio tone normalizes and the intelligibility improves.
Okay, I'm tuning a little low. Upper sideband. Now I'm going to tune him in again. That sounds pretty good now.
With no designated channels to help ensure that signals remain separated, it is quite common for two signals to overlap in the frequency space. When a second undesired signal interposes itself with the desired signal being received, Some portion of the undesired signal will be demodulated into audio along with the desired signal, and this will produce interfering audio, also called QRM. Operators should take care to make sure there is sufficient unused band for the bandwidth of transmitted signals, helping to reduce the possibility of QRM. Further, using receive filters to narrow the receive bandwidth can help isolate most of the desired signal while the adjacent interfering signal is attenuated and silenced.